Hi guys, welcome to all of you. Guys, please confirm once that am I audible to you or not? How are you, Shillong? Can you see me? Hi. Hi. Okay. So guys, how are you doing? All good? Hi, good evening, Shillong. Oh, yes, good evening. You guys directly come from the school? I mean, directly from the school to the center? I guess because you're looking in the school dresses. Okay. Yeah, I have seen you. Okay. By the way, what's your name, guys? I think I haven't know any of name of any person in the Shillong Center. Sorry, sir. I think two are sorry. The name of two person is sorry. They can raise their hand. And one is sir. I guess sir is me. What about you? Oh, just kidding. Okay. What's your name, guys? I'll write one by one so that I can. Okay. So who is Rida? Have I pronounced it correctly? If not, then I apologize for that. Who is Rida? Okay, Rida is there. Who is Sweetie? Okay. And obviously you are the Mandy. Hi, Mandy. She's busy with her typing, giving answer for everyone. Okay. So guys, tell me what topic are we discussing in the last class? Or do you have any doubt or query for me? If you want to ask me anything, any doubt, you can please ask me. Please share the topic which we were discussing in the last class. Hi, Mr. Latecomer, you are late today. What's your name, dear? May I know the name of this person, please? Please show the centers connected. Itanaga, are you there? Am I audible to you? Hi, Eliza. Oh, hi. There are two new students. Oh, three. Hi. Hi to everyone. Am I okay? That's cool. So guys, let's start with our class. Please share the topic that we were discussing in the last class. I guess we were discussing about the dipole moment. That's what I remember, but I don't know up to which point we have discussed. So please share the last topic, no? No, topic is dipole moment, but I don't think so that we have completed the dipole moment. I guess the last topic was symmetrical elements. We were calculating the dipole moment for the symmetrical molecules, means the molecules which are having the symmetry, isn't it? Okay, very good. I guess so. I have told you that they are non-polar molecules because they are having the symmetry, or we can say that simply that just because of, if I calculate the net dipole moment, that net dipole moment would be 0. Okay, that's why they are termed as the non-polar molecules. Okay, so let's continue after that. Okay, now case 2, unsymmetrical molecule. Guys, means these molecules are those molecules where we won't get any symmetry over there. Okay, or we can say if all bond pairs are not present in a molecule, there is a lone pair that will also result into the unsymmetrical molecule. Okay, so let's take an example of ammonia. See, we can draw ammonia like this. Okay, if you check out, this should be the direction of the dipole moment, this and this. You can check out that the 3 dipoles are moving away from the effective center, which is the nitrogen, and one is moving another direction. Okay, but the point is this dipole, I am talking about this one. See, here the movement of electron pairs is towards the lone pair of electron, okay, which is a non-bonded state. Here these dipoles are present where bonded pairs are present. Okay, so guys, here the point is the magnitude of the different dipole, means the dipole which is in the which is pointing in the upward direction, and the rest of the dipoles which are moving in the downward direction, as we can see in the molecule. Okay, so they are not having the all equal molecule, all equal dipole moment. Okay, that's why here the net dipole moment is not 0. Okay, and if I would like to summarize it to make it easy, you can simply remember that whenever electron pairs would be there, there is an absence of symmetry, and if absence of symmetry is there, it wouldn't be there won't be the net dipole moment 0 over there. Okay, that's why we will say it is a polar molecule, because net dipole moment is not equal to 0. Okay, have you got that? Itanagar, Shillong. Was I too fast while discussing this molecule? If you are having any doubt here, please you can ask me. I'm repeating, guys, please don't feel shy. Okay, you can come up with your doubts, you can ask me your doubts. If you are having the doubt, you are most welcome. Okay, I'll repeat it. Wait. First of all, copy this, then I'll take another example to explain it. Have you copied that? Itanagar, are you there? Okay, fine. Okay, Shillong, got it. Itanagar. Dear, are you getting this? Okay guys, I'm repeating this. Just look at the screen. Need not to copy this. This is just for the understanding purpose. Okay. Look at this. I'm taking an example that this is A, B, C, C and C. There's another molecule which is A, B, D, D and D. Okay. Now, okay, let's make it D. Let's make it D. Okay. I'm saying that D is more electronegative than A. Do not copy this, guys. Do not copy this. Just look at the screen. I'm saying that D is more electronegative than A. And first of all, guys, remember this formula that dipole moment is equals to what? Charge into distance. I hope so everybody knows this formula. Okay. And representation for this one is what? This. Now look at this. Obviously, all the dipole will move away from the center. Okay. So obviously there is a symmetry as well in the molecule. Okay. If you don't want to understand by the help of the symmetry, you can simply check out that all the dipole which are having the equal magnitude. See, here the dipole moment is between A and D. Here as well between A and D, A and D and A and D. So obviously all the dipole, we can say that all the dipole moments will have the same magnitude. Okay. So what can I say? They will just cancel out each other by the help of resulting dipole moment. I think so. You have also studied about the resulting force in the physics. Okay, it is relatable to that. Okay, if I say that all the dipole moments having the same magnitude over there and they are moving away from the center. Okay, so obviously if I ask about the net dipole moment, what will you say? It is 0, because all are what? Equal. First of all, tell me, are you clear with this one? If you are not still clear with this one, you can please tell me. I'll take another example. Are you clear with this one, that here the dipole moment of every molecule means the 4 dipole moments are exactly same in the magnitude and they are away from the center. So the resulting dipole moment would comes out to be 0. That's what I'm saying. Are you clear with this one? Just confirm it once. Okay, good. Now, move on to the example number 1. Here I am saying the electronegativity of B is greater than A as well as C is greater than A. Okay. Remember, electronegativity of B is not equal to C. Okay. So, let's check out. Direction of the dipole, direction of the dipole, direction of the dipole, direction of the dipole. Now, my question is, this is first dipole, this is second dipole, this is third, this is fourth. Can you please tell me that all the dipoles having the same magnitude? Look at the screen and tell me, is all the dipole can have the same magnitude of the dipole moment in the molecule number 1? I have already said that electronegativity of B and C are not equal. Are you getting this? Again got confused? Okay, I can see a sign. Okay. Okay, that's good. So here you can check out that the all dipole moments are not same, means that resultant would never be 0. Are you understanding this? That resultant would never be 0 if all the dipoles are not same magnitude or of not same magnitude. Okay. Just use it here. See, the electronegativity of hydrogen and the lone pair is not same. Okay. So that's what I am saying. Whenever we conclude the something resultant, okay, it will not are cancelled out completely. Okay, therefore it will have certain dipole moment over there. That's why we can say it is a polar molecule. Or in simple words, I can say whenever a lone pair is present over there, there will always be the dipole moment. Always, it is true. Now tell me, are you clear with this one? Now are you clear with this one? Okay. Okay, good. Now my question is for you. NH3 or NF3, which one will have higher dipole moment and why? I am giving you 2 minutes to attempt this question and tell me the answer. Remember, NH3 and NF3 both have the similar shape. Think about it and tell me the answer. Okay, why? How many of you has got the answer NH3? Raise your hand. Itanagar, what's your answer? Raise your hand those who are saying NH3 should have the higher dipole moment. NH3 should have the higher dipole moment. Raise your hand. The Shillong Center. Okay, 1, 2. Okay, the whole class. Very good. Okay, Shillong, your answer is correct but not explanation. Let's check out. See. And this is your NF3. And very important question, guys. This is for the school examinations. If we check out the direction of the dipole, because nitrogen is more electronegative than the hydrogen, okay, you can check out all the dipoles. If I talk about the resulting dipole moment, so I think so they will be moving in the upward direction. Okay, means I can say there is a net addition over there. What can we say? There is a net addition. If I talk about this one, fluorine is more electronegative than nitrogen. That's why the dipole will move away from the center. And here direction should be this one. So you can check out, guys. Guys, even in the first case, wait, we need to change these arrows because electronegativity of nitrogen is greater than hydrogen. Please change these arrows. Always movement will be towards the more electronegative atom, na? Change these arrows. Done. Confirm once after doing that. Itanagar, have you done that? Okay. So here you can check out net subtraction is there. Okay. Therefore, the dipole moment of NS3 will be higher than the NF3. Okay. Copy. Have you got this, guys? Are you feeling comfortable while understanding the chemical bonding, concepts of chemical bonding? Guys, this is the backbone of the inorganic chemistry. If you are having any doubt, you can please ask me. Are you clear with the topic till now? Copy and then confirm. I'm repeating, guys, please don't feel shy and don't get panic. If you don't get any concept, just let me know. I'll repeat it. Or I'll make sure that I'll take the another example to make it clear to you. What you have to do, you have to just tell me. Okay, next question for you. Our shape will be drawn like this, that we have just done previously. Arrange the following in the order of increasing dipole moment. CHCl3, CCl4, CH2Cl2, CGH4. Do this question, guys. In spite of writing CH4, make it CH3Cl. Yeah, this is a much better part. Make it CH3Cl. Now do this question and tell me the answer. Done? Itanagar, Shillong, have you done that? Guys, if you have attempted that, just please let me know so that we can proceed. Okay, let me help you out in this one. See, let's draw the structures first. This is CHCl3. This is CCl4. This is CH2Cl. This is CH3Cl. Just keep in mind one thing, the electronegativities, and just draw the direction of the dipoles. Okay. Let's, for example, I am drawing it for you for the first case. Carbon is more electronegative than hydrogen, therefore direction should be this one. Here, chlorine is more electronegative than carbon, therefore direction would be this one, and this one. Okay, like here. But the point is, if you check out the second molecule, it is actually symmetrical molecules. All are the CCl bonds. Okay, so its dipole moment would be 0 actually, guys. So it's very easy. That's in the point number 2, it will be 0. Okay, but we know that the CH and Cl bond has the different electronegativities, so they will have the different magnitude of the dipoles. Second thing, I have told you that formula of the dipole moment is what? Charge into distance, and it majorly depends on the magnitude of the charge, not on the distance. Okay, it majorly depends on the charge. So just think about it, which electronegativity difference can create the higher charge, and which can create the higher charge will have what? Higher dipole moment. Okay. In the same manner, you can draw for all these and think about it. Or you can simply check out that where is a net addition higher and where is net subtraction is higher. Okay, this will definitely help you out in this one. Check out. Tell me what should be the order. Okay, think like this. Where you are getting the maximum dipole which are moving in the same direction. think like this, where you're getting the maximum dipole which are moving in the same direction. Not working, guys. Okay, check out the molecule A, which is CHCl3. See, CCl4 is a 0, so just leave that. Okay, other 3 is definitely having the more than 0. Now let's differentiate between 1, 3 and 4. So CHCl3, in CHCl3 there are 3 dipoles which are moving away from the center and 1 is moving towards the center. Okay, so 3 away, 1 inwards means that the direction is something outwards. Now if I talk about the molecule number 3, you can check out that the two dipoles, one second, here this direction should be this one, towards the carbon. You can check out the 2 dipoles are moving towards the carbon and 2 are moving away from the carbon, means 2 inwards, 2 outwards. In the last case, 3 are moving towards the carbon and 1 is moving away from the carbon. Okay, on the basis of this one, think about it, where you can get the maximum value. Here in the case 1, 3 away, 1 towards. Here 2 towards, 2 away. Here 3 towards, 1 away. It is like away decreases the net dipole moment. I am saying away decreases the net dipole moment. Now think about it. Where you will get the least dipole moment among these 3, except the CCl4. I am repeating. Away decreases the dipole moment. Okay. Itanagar, are you there? Shillong, are you getting this? Itanagar? Okay, Itanagar has given the answer. Absolutely right. Yes, Shillong, that's absolutely right answer. Who has given this answer? Please raise your hand. Raise your hand, those who has given this answer. One, two, three. You were trying to raise your hand or you're just confusing me? Okay, very good. Yes, very good. See, 3 away will decrease the dipole moment very high. Okay, so let's write the order. CCl4, after that 3 away will have the least one, which is CHCl3, or then 2 away, which is CH2Cl2, and then 1 away, CH3Cl. This is the order. Got it? Got it? Or still having some doubt? Say something yes, no, or yo, whatever you want to be. Okay, this is the new one. Oh, okay, like this. Yeah, that's better. Yeah. Okay, Itanagar, have you got that? Okay, Itanagar is saying the same. Yo, that's good. Yeah. Okay, so let's move on. Guys, now I'm going to discuss the formula with you, okay, of the dipole moment. See the net dipole moment. Let's say suppose we are having the 2 dipole moments mu1 and mu2, okay, and we have to calculate the resulting dipole moment. So resulting can be calculated by the help of formula, which is under the root mu1 square plus mu2 square plus 2 mu1 mu2 cos theta. I guess so you have already studied this formula of calculating the resultant vector in the physics as well. Have you seen this formula before, na? Yeah. Nice. So just copy this formula and use this formula while solving this question. Mu1 is equals to mu2 is equals to x. Okay. Calculate when first part theta is 30, theta is 45, theta is 60. Yeah, that would be enough. Or you can take this one as well, 90 as well. Yeah. Guys, please attempt this one and just let me know that you have attempted that. Okay. You have attempted that. Okay. Itanagar, no for what? Are you having any doubt? Okay, for this formula, guys, this is the formula of the resulting dipole moment. Okay. Please attempt this. Just get your values and then just let me know. After that, I'll solve this and we will conclude something on the basis of this one. Very important part. Done? Okay, let me start. If you have attempted that, then I'm going to start, guys. Just look at the screen. For the first part, mu would be under the root x square plus x square. Okay, very good. Plus twice of x into x cos 30. Cos 30 is what? Root 3 by 2. Okay. So what can we get? We will have 2x square plus root 3 x square. Okay. So I think so we can take x common. So this is what? Under the root 2 plus root 3. This is the first part. Number 2. X square plus 2x square cos 45 is 1 by root 2. Okay. So what can we do? This is 2x square plus 2 upon root 2 x square. So I can take common x square again, so x will comes out to be here, and inside we will get what? 2 plus 2 upon root 2. Okay, this is the second part. Third part. X square plus 2x square into 1 by 2. Okay. So this is 2x square plus x square. So this is root 3x. Okay. Fourth part, x square plus 2x square. Cos 90 is 0. So this one will become 0 and you will get what? Root 2x. Okay. So what can we say? First one is what? X into root 2 under the root 2 plus root 3, then 2 plus 2 by root 2, then root 3x, and after that root 2x only. So actually what can we conclude from here? That this is mu 4, mu 3, mu 2 and mu 1. Actually what can we conclude? That mu 4 is less than mu 3 is less than mu 2 is less than what? Mu 1. So actually what I would like to conclude here, that the angle was gradually increasing, 30, 45, 60 and then 90. Okay, angle was increasing. So with increase in angle, dipole moment was decreasing over there. Okay. So guys, what you can do, you can make a note of this one, that dipole moment is inversely proportional to what? Bond angle. Are you getting this? That dipole moment is inversely proportional to what? Bond angle. Higher is the bond angle, lower will be the dipole moment. Okay. So this was the conclusion for that particular question over there. Okay. If you haven't noticed, note that, you can please note, copy it. By the way, how many of you has got the same answers? How many of you has got the same answers? Okay, that's really good. Okay. Anyone who is copying it, please copy this and then we'll move on. Okay, copy this one as well. Any doubt, guys? Just confirm once. Shillong, Itanagar. Are you clear with this one? Okay. Then note down this. This is the important part. Okay. See, the same concept would be used in organic chemistry as well, where we will use where we want to find out the dipole moment of the organic molecules. Okay. Now, next important formula, that percentage ionic character. Okay. The formula is experimental value of mu, which is given in the question most of the time, upon theoretical value of mu into 100. I hope so everybody has studied about the units of the charge. Okay, please copy this formula and then let's practice a question. Calculate mu of HCl if bond distance is 1.34 angstrom, charge 4.8 into 10 to the power minus 10 ESU. I guess I have told you what ESU stands for, and calculate percentage ionic character if experimental value of mu is 1.08 dBi. Okay, guys, read the question very carefully. Okay, you can check out the units of the charge. Okay, both units should be same, either in the electrostatic unit coulomb and electrostatic and the meter, or it both should be in the dBi. Okay, so just give an attempt. After that, I'll discuss with you. Just give an attempt. Open up your mind and break this question. I mean, crack this question. Attempted? Itanagar, have you done that? Guys, please mark your attendance once. Itanagar and Shillong, please mark your attendance. Okay. Okay. Okay guys, so let's start. See, first of all, you need to calculate the mu, na? Just use Q into D. Q is given to you 4.8 into 10 to the power minus 10. Okay. Then angstrom. So just convert angstrom into the centimeters. So it one will be 10 to the power minus 8. Just solve this. And after solving, this one will be approximately 6.4 into 10 to the power minus 18 ESU centimeter. Okay, so this is the mu, which is a theoretical value that we have calculated by the help of formula. Experimental is given to us. Okay, so first pass has been completed. Now let's check out for the second part. Percentage ionic character. So this is experimental upon theoretical. Experimental is 1.08 dBi. Convert this dBi into the ESU coulomb meter. Sorry, ESU centimeter. So for that, just multiply it with the 10 to the power minus 18 upon 6.4 into 10 to the power minus 18 into 100. Just solve this, and after solving, I'll guess you will get nearly 17%. Copy and confirm. Done that, guys? Have you done that? Any doubt about it? Are you clear with the question? Okay, so let's move on. One more question for you guys. Which one will have higher dipole moment? H2O or H2S? Tell me. Check out this question and tell me the answer. Keep in mind charge. This time Elizo will say the answer. Elizo, doesn't mean that all the rest of the students will be keep quiet, means they won't answer. Okay, very good. Yes, answer would be H2O. Why? See, the shape would be same for H2O and H2S, but the problem is oxygen is more electronegative than hydrogen, therefore the charge created on the oxygen, or we can say the charge difference between hydrogen and oxygen, would be very high. That results into what? Higher dipole moment. Okay, got it? Got it, guys? Okay. Next topic is polarization. Means covalent nature in ionic bond. This is your Fazan's rule. Fazan's rule we have to discuss, guys. Means till now we were discussing the ionic nature in the covalent bond. Now reverse would be there, that covalent nature in the ionic bond. Okay. First of all, I think so everyone is clear with this point, that the ionic bond are formed by the sharing of the electrons. Okay. When a cation and anion approaches to each other, okay, then after a certain distance, they cannot we can say that they cannot pull each other towards themselves, okay, and that state is known as what? Bonded state, that we have learned in the covalent bond as well. Okay, means there is an equilibrium state where attractive and the repulsive force are just balanced over there. Okay, same is happening over here. Now the question is how covalent character can be developed in an ionic bond. Okay, we have to discuss about that. So first of all, let's write the definition of the ionic bond, and then we'll proceed with this one. Okay, so just write down an ionic bond is formed by transfer of valence electron. Okay, this is the formation of the ionic bond. Now guys, look at this. See, this is a cation and this is an anion. Okay, we know that anion carries the negative charge and cation carries the positive charge. Okay, so what actually scenario is, the anion has the electron pairs over this one, because it is a negatively charged, it means it contains the electron pairs. So what happens then, whenever they come closer to each other, cation pulls the anion towards itself with a very strong force. Okay, due to which what happen, that some part of the electron cloud, or we can say some part of the negative charge of the anion, get deformed over there. Deformed means See, you can see here anion is a spherical symmetrical over there. Now, when they approaches each other, see, this was the initial scenario of anion. What happened? That certain electron clouds are got deformed. Now, this is the actual scenario right now. So, whatever part of the electron cloud, we can say whatever part of the electrons present on the anion is pointing towards the carbocation is actually get neutralized over there. Okay, and that neutralized part becomes a, or we can say that neutralized part is known as what? Covalent character in an ionic bond. Okay, are you getting this? That the electron clouds of the anion get deformed and it gets neutralized by the help of the positive charge of the carbocation, and that neutralized part is known as what? Your percentage of covalent character in an ionic bond. Okay, and the remaining part will remains the same in the form of the ionic bond over there. Okay, so this deformation is known as what? Polarization. Okay, so always polarization will be done on the anion, and polarization, the reason for the polarization is what? Carbocation. Means carbocation helps in the polarization process over there. Okay, first of all, tell me, are you clear with the current example? Are you clear with the current example that it is nothing but the deformation of the anion? If not, you can just please tell me. Are you clear? If not, you can please tell me. Okay, say something, yes, no, yo, whatever you want to be. Okay, yo, this one, that's better. Okay, that's good. Okay, nice. So, just copy this one, then I'll write all this, what I was discussing. Whatever I was discussing, I'll write it for you. Just copy this and confirm. Okay guys, so let's start writing this. You can please copy along with me. When a cation approaches an anion, closely the positive, guys, you have to copy this one with me, charge of cation attract electron cloud of anion towards itself. Due to electrostatic force of attraction between them. at the same time cation also repel the positively charged nucleus of an ion. Due to this combined effect, cloud of an ion elongated towards the cation. This is called distortion. Or polarization. Of an ion by cation, and develops covalent character. Copy please. Guys, remember one thing, higher is the polarization, higher would be the covalent character. Higher polarization means higher neutralization of the charge, means higher distortion, and that would results into the higher covalent character in an ionic bond. Okay, so that depends on a certain factors that is given by the Fazan. Okay, so we have to discuss about those rules. Okay, copied. Itanagar Shillong. Okay, so let's discuss about the Fazan's rule. Factors affecting polarization, which is Fazan's rule. Now guys, keep calm, take a deep breath, and after that think about it what I am trying to say. Okay, remember, whenever we get a good questions for the crack, or we can say that to crack those good questions we need to use our brain and we should be clear with the concepts. Okay, so just keep in mind, higher is the polarization or the distortion, means higher covalent character. Okay, just keep in mind, and then by use of this one I am going to discuss one by one each and every factor. First is saying size of cation. Now you tell me, now you guys have to tell me that if I compare the two cases where let's suppose A and B, I am saying size of B is greater than A. where nuclear force will be high in case of B or A. Size of B is high. Now my question is, where higher nuclear force would be present, in A or B? Okay, Itanago. Guys, do I need to repeat my question? I was just asking that the size of B is greater than A. Now my question is, see, both are the cations. Both are the cations. Don't confuse with that. This is cation, this is also cation. Do not copy this, guys. This is just for concept clarification. I'm asking, where nuclear force will be high, means which cation can experience, or we can say can make experience higher nuclear force. I hope so you understand the meaning of the nuclear force. It is the force of attraction applied by the nucleus, means force of attraction by the nucleus. Think about it, guys. Okay, tell me one thing. If size increases, then on the outermost electron, nuclear force increases or decreases? If size increases, then attractive force on the outermost electron increases or decreases? Yes, absolutely right, Itanagar. Shillong, what happened? Are you clear with my question? If size increases, then the force of attraction on the outermost, yes, absolutely, it decreases. Okay. If force of attraction decreases, it means that nuclear force was decreasing. That was the relation. Okay. Now, if nuclear force is less, it means that the attracting power of the anion, the attracting power of the cation to attract the anion would be less. Okay. If attracting power of cation is less towards the anion, it means that there will be lesser deformation in the cation, in the anion, means electron clouds of the anion will be deformed. Okay, very less if attractive force is less. Okay, so I was just trying to convey you that if size of cation is small, it means that there will be the higher force of attraction. If higher force of attraction is there, it means that it has great ability to attract the electrons towards itself. It means that higher deformation, and higher deformation means that higher development of the covalent character in an ionic compound. Okay, so actually what should we say on the basis of this one? That polarization, remember guys, polarization always related with the anion. Is inversely proportional to what? Size of cation. Confirm how many of you has got this one, or still having some doubt? Okay, raise your hand those who has got this one, means clear with the concept. And Itanagar, you can use your chat screen please. Okay, very good, just copy this, and after that let's do a question. Okay, check out the question. Arrange the following in the order of increasing covalent character or polarization. Okay, the molecules are BeCl2, MgCl2, CaCl2, SrCl2. Do this question. See, anion are exactly same, Cl negative, but cations are different. Now you need to identify from which group they all belongs. That's why I have told you periodic table, the learning of periodic table is very, very important. That's why I have given you some tricks as well, some mnemonics as well. Okay. Arrange. And just confirm the answer on the screen. Got the answer, guys? Very good. Absolutely right. Raise your hand, those who has got this answer. Raise your hand. Itanagar, I haven't got answer from you, dear. Please do write your answer. Shillong can raise their hand, those who has got this answer. Okay, got it. Guys, one thing, whenever you have to raise your hand, be confident, show your confidence. Okay, I can see some of the students who are just raising their hand just like this. Means this shows that quite low in the confidence. Okay, whenever you are confident about your answer, means in your turn, what you have to do, you have to just give an perfect attempt. Okay, you can never predict every time that what can be the correct answer. Might be I'm dealing with an exception, but according to the concept, you have to just make sure that I have applied the concept very correctly. Okay, don't think about the result. Just think about that whether am I able to apply the concept or not. Okay, and after that, whenever someone, anyone from your school, from your classes, anyone, if ask you that you have to raise your hand, just be confident like this. Just you have to raise your hand. Yes, this the level of the hand is shows your confidence. Okay, just it should be like a straight. Okay, don't do this. Okay, yeah, try to be like this. Okay, yeah, that's like. And yes, this is the good one, but only in my class, not in your school. Okay. Okay, now please raise your hand, those who has got this answer. Raise your hand. Now no one is raising their hand. Okay. Yeah, that's like my student. Yeah, great. Okay. Eliza, why are you not raising your hand? Haven't you attempted that question? I hope so I have pronounced your name correctly. If not, then I apologize. I think so that that name was written on the screen. Okay, very good, Itanagar. Yes, guys, the answer is this one. C. On moving down the group, size of cation increases. So beryllium should have the smallest size and Sr should have the biggest size among all these. So this one will be the order. Got it? Very good answer, guys. Okay. So let's move on to the next point. Point number 2, size of anion. Elazar. Okay, size of anion. Okay, now you tell me, if size of anion is large, then it is easy to deform them or it is difficult to deform them? My question is if size of anion is large, then is it easy to deform them or it is difficult to deform them? If size of anion is large. Have you got my question, guys? Please, whenever you do not get my question, just you can ask me that, sir, please repeat, or we are not getting your question. Okay? I was just asking that if size increases, okay, then with increase in size, whether it is easy to deform the anion or it is difficult to deform the anion. Deform means, what is the meaning of deform? Means ultimately, where they can feel the higher force of attraction. Okay, now you must be get confused in this one. Okay, don't get confused. Means in which case of the size of the anion, electron clouds would be loosely bounded. Means the force of attraction will be experienced by the anion or the electron cloud will be less in case of bigger size or the smaller size. Have you got my question? Yes, absolutely right, Itanagar. Yes, this one, absolutely right, Shillong. That if size is bigger, it means that it will feel the less force of attraction, means it is easy to deform. Okay, and higher is the deformation, higher will be the covalent character. So what can we say? That polarization is directly proportional to what? Size of an ion. Now question is for you. NaCl, not NaCl. This is CF2, CaCl2, CaBr2 and CaI2. Arrange them in the order of increasing covalent character. Increasing covalent character. Do this and then tell me the answer. Guys, you have to write your answer on the screen. Itanagar and Shillong. Okay guys, you are taking too much of time. See, fluorine, chlorine, bromine, iodine belongs to the same group. So on moving down the group, size increases. Calcium is common in all of them. So this should be the answer: CaF2, CaCl2, CaBr2, and then Ci2. Okay. Yes, this is the answer. Nice one, Shillong. Very good. Okay, just copy this one, guys. Let's move on to the next point. Next part, that polarization is directly proportional to charge on cation or charge on anion. Remember one thing, for such questions you have to compare either cation or anion. Please do not compare cation with the anion. Okay, comparison must be between two cations, means charge charge on two cations, and or we can say charge on two anions. Okay, don't compare the charge of cation with charge of anion. Okay, remember one thing. So just check out this question. Let's suppose we have got NaCl, MgCl2, AlCl3, SiCl4. Okay, arrange them in the order of increasing covalent character. See, chlorine is same in every atom. Okay, sorry, every molecule. So we have to just check out the cation part. Okay. See, one chlorine means one positive charge, means one chlorine can create one positive charge. So if two chlorine are there, they will create the two positive charge. If three chlorine are there, they will create the four positive charge. Okay, on the atom which is in front of the chlorine. Okay. On the basis of this one, just do this question. Done? Are you done with that, guys? Okay, let's check out answer. See, as I have told you that one chlorine means one negative. It means this is Na plus, this is Mg2 plus, this is Al3 plus, and this is Si4 plus. So on moving left to right, positive charge increases. It means that covalent character will also be increased. So what can we say? That NaCl, then MgCl2, then AlCl3, then SiCl4. Shillong and Itanagar, guys, please confirm once. Have you got that? Have you got this question? Are you clear with the concept? Oh wow, great. Shillong and Itanagar has given the answer at the same time. And this answer is, oh, even I2 has got the same answer. Very good. Means we all are doing really good because we all are having the same answers. Great. Okay. So guys, let's wind up this one, today's session. Okay. So I'll see you next time. Okay. So thank you so much, guys. Till then, take care. Bye bye. Have a good time. Okay. Enjoy yourself for DS. Please study as well. Okay. So see you next time. Bye bye.